Hello everyone, this is Xin Liu from Purdue University. So today I'd like to talk about some new added functions in the TexGen4SC on the cdmHUB. Basically, we enable a two-step homogenization approach for the textile composites. So a little bit background. For textile composites, we consider it has different scales. So we first need to perform so-called microscale analysis to get the effective yarn properties based on the fiber and the matrix properties. Once we have the yarn properties, we can perform a so-called mesoscale analysis to get the effective properties for the textile composites or woven composites. And these effective properties can be a material stiffness matrix, which can be used to define solid elements for the structure analysis. Or it can also predict the beam stiffness matrix or plate stiffness matrix, which can be used to define beam or shell elements in the structure analysis. So this is a unique features provided by the mechanics of structure genome. For the detailed information about this two-step homogenization approach, you can refer to this paper. So the new added functions in the TexGen4SC can be summarized in this slide. Basically, at the microscopic, we provide two different micromechanical models, square peg model and hexagonal peg model. And for the functions, we can predict the effective elastic properties, thermoelastic, viscoelastic, and thermoviscoelastic. And the corresponding theory of using mechanics of structure genome can be found in the reference listed here. Okay, so let's first work out the first example. Our goal is to use this two-step approach to predict the effective properties of plane wave composites. At the microscopic, we use hexagonal peg model, and at the mesoscale, we have a plane woven composites. And this is the first example in this paper. So if you follow all the steps, you will reproduce the results in this paper. Okay, so let's first go to the cdmHUB. Let me log in to my account. Okay. So if we go to the TexGen4SC, we can launch the tool. Okay. So the first step is to create the corresponding woven SG. So here I need to unselect this at 10% to the domain head. So click next, create the plane woven SG. Okay, and then we can perform the first step homogenization, which is at the microscopic. Here, remember we want to use the hexagonal peg, and we perform elastic analysis, and the material properties need to be changed here. Let me input the corresponding one. So we want to perform the elastic analysis. Although we have the CTE properties here, but we when the TexGen4SC really perform the analysis, it will not consider this because we select this elastic analysis. Okay, and the volume fraction is so all the information you can find in this paper. So let me double check what is the volume fraction here. Okay, so the volume fraction is 80%. Okay. Then it should be 0.8. Okay, and then I click finish. It's very fast. Then we can get the effective properties of the yarn properties, and you can check the results with the paper. And in the paper, we also did the 3D FEA to prove the accuracy of the MSG theory. Okay, and then we are ready to perform the second step, which is the mesoscale analysis. You can see actually it will define the effective yarn properties, automatically define the effective yarn properties to this mesoscale structure. So if we select a yarn, and to double check the yarn properties, you can see all the properties which from the microscopic has been assigned to the corresponding engineering constant. But here we also need to change the material matrix properties, but it's only matrix properties. We only need to input 2 values here, so it will not be a big deal. Okay, now we have the mesoscale structure ready, and we can go ahead and generate the corresponding SC file. So in this first example, we have the total 16,000 C3D8 elements. So we actually have the voxel mesh divided like this. Okay, and elastic analysis, solid model, click finish, and then we save this file. Elastic. Okay, and save. And we can check the corresponding time. And then we just go ahead and click the mesoscale. You can see actually it was pretty fast, and we have all the effective engineering constants, and you can follow this step and get the corresponding results and check with the results in the paper. And the 2 points I want to mention, because I have got a lot of questions about this first example. So first you need to unselect this 10% domain head. Okay, no 10% domain head, and then the voxel mesh would be 40, 40, and 10. You may observe some very, very small difference between these results and the results in the paper. That is because of the mesh used at the microscale is different from the model in the paper, but the difference is really small. Okay, so this would be our first example.